You are welcome to chemistry class today, once again with an quick Christopher GK. In this particular video, we are going to be looking at a topic titled chlorine. We want to look at an element in our periodic table, chlorine, to know what it makes up, what it's made up of. And it's expected by the end of this class, we should be able to explain the element chlorine, explain the laboratory and the industrial preparation of chlorine. You also will learn how to discuss the properties of chlorine, both the physical and chemical properties of chlorine. Then you state the test and the uses of chlorine. These are the things we want to achieve by the end of this particular video. So let's follow them one after the other by starting with what actually is chlorine. So first of all, chlorine is a chemical element. Of course, we have in the periodic table with the symbol C, capital C and small l, is being written together, and the atomic number of 17. Now, chlorine is the second lightest of the halogens, which is the group 7. It appears between fluorine and bromine in the periodic table, and its properties are mostly intermediate between that of the fluorine and the bromine. So, chlorine is a yellowish greenish gas. It's a yellow greenish gas at room temperature, at normal room temperature, and it has an extremely reactive element, and is a strong oxidizing agent. Among the elements, it has the highest electron affinity. So chlorine is extremely reactive. It's a strong oxidizing agent. Its oxidation state varies depending on the compound element it's bonding with. It has oxidation number of -1, +1, +2, +3, +4, +5, +6, and +7. It depends on the element it's bonding with or the state it found itself. All right, we can prepare chlorine in the laboratory with this particular setup. You can see on your screen. In the laboratory, we prepare chlorine using this setup. And how is it? As you can see, you can see it being clamped with the setup being well set up. The manganese oxide, conch hydrochloric acid, water, conch H2SO4, cardboard, and the dry chlorine. So let's get it explained. How is it being prepared in the lab? Now, chlorine is usually prepared by the oxidation of concentrated hydrochloric acid, as we saw it there, with a strong oxidizing agent such as manganese oxide. Look at manganese oxide here, and the hydrochloric acid being poured on it through the test tube funnel. Now, the manganese oxide is heated with concentrated hydrochloric acid, and the gas produced is bubbled through water to remove any hydrogen chloride gas present. Now, the chlorine is dried by passing it through the concentrated tetraoxosulfuric acid. Of course, it's a drying agent, and is being collected by upward displacement of air or downward delivery in the fume cupboard. Look at it, as you can see. Downward delivery, we can see it here, or upward displacement of air. All right, the equation is here of all the things that happen in the setup. You just see. That is how we prepare chlorine in the lab. Look at it, chlorine gas is being produced. Chlorine gas is being produced here. All right, other methods of preparing chlorine includes using potassium tetraoxomanganate 7. Now, without heating, potassium permanganate oxidizes to liberate chlorine. It oxidizes to liberate chlorine. The same apparatus as we used in the other one is used as in the first method, but if dry chlorine is not required, the gas could be collected over brine. Brine is concentrated sodium chloride. Now, This is the equation for the reaction. Potassium permanganate, which is potassium tetraozo manganate 7, reaction with concentrated sodium hydrogen chloride. It have this, and chlorine, as you can see chlorine here, it will be produced. All right, it's being collected are the same like the other one through downward delivery or upward displacement of air in the same setup. All right, but industrially, in the industry, chlorine is produced using different setup and in a different way, because you know they have been produced in a larger way. Now look at the setup that is being used and how is it being done. It's been done in this way, that is being prepared by electrolysis of brine by the use of a Castiner process. Concentrated sodium chloride, which is brine. Concentrated sodium chloride is brine, as you can see it in the setup. Now the cell is made up of two compartments. A thin layer of mercury flows at the bottom. The two compartments are separated by a partition, which deep down the mercury. On the other, of course, they deep down the mercury, and on the other passage, on the passage of the current through the sodium chloride solution, which is the brine. Concentrated sodium chloride is brine. Through that, chlorine is liberated at the anode, which is A, and is being moved out through a pipe in compartment. As you can see it here, as you can see chlorine here, that is where it's being liberated from, through the compartment. As you can see the outlets of chlorine, and we also have it here in the two sides. All right, sodium is deposited at mercury, which is the cathode of the compartment, and forms sodium amalgam. Of course, mercury is the anode and V is cathode, which is made up of what? Iron rods. Sodium is liberated on V, where it reacts with water to form sodium hydroxide and hydrogen. Now sodium, the hydrogen moves out through the pipe, and the sodium hydroxide is run out, evaporated, and cast into stick as byproducts. Sodium amalgam produced during this process can be dissolved in water to give sodium hydroxide solution. Hydrogen and form sodium hydroxide solution, hydrogen and the mercury. As we saw it there, the mercury generated is returned to the cell, as shown in the figure above, in the diagram here. All right. The equation: sodium chloride ionizes, of course, the sodium, which is the concentrated sodium chloride, which is the brine, ionizes, and the water also does its own. Now, sodium ion and the hydrogen ion move to the mercury, which is the cathode, of course, and the sodium is discharged. And when it does that, it will combine with mercury to form sodium amalgam. Or what we just did, what happened there is just what we are using chemical equation to represent. Of course, electrolysis, the cations will move to the cathode. Now, the chlorine ion and the hydrogen ion, of course, two of them will move to the anode, which is the positive electrode. And the chlorine is discharged because it is present in greater concentration. This is the factor, one of the factors that affect the discharge of ion during electrolysis. The concentration of ion is one of the factors. So chlorine will be discharged in preference to hydroxyl ion because it's concentrated, and that way it will be displaced there. All right, what are the physical properties of chlorine? Chlorine is a greenish yellow gas, which has a choking, unpleasant, and irritating smell. It is denser than air, and it's moderately soluble in water. Chlorine can also be liquefied under pressure for about 6 atmospheres, and it's a poisonous gas. And if inhaled to a very small amount, it can damage the mucous lining of our lungs. So it's a poisonous gas. It's not to be inhaled at all. But the physical behavior, the chemical behavior of chlorine is this. Chemical behavior or chemical properties are these. Number one is displacement of other halogens. Of course, we know that we say that is a very reactive halogen. Except fluorine, chlorine displays other halogen from solution of their acid or salt. Bromine, iodine, it displaces them because it's more reactive than them. Of course, you can see chlorine react with sodium bromide, chlorine react with hydrogen halide, sodium react with hydrogen and sodium halide, and it displaces them from their salt and the hydride of iodine. So that with that, hydrogen halide is an acid. So with that, it displaces them because it's more reactive than that. Displacement of other halogen except fluorine. All right, another one chemical reaction is direct combination with other elements. Of course, chlorine will react with other elements. It will react with metal. When it reacts with sodium, it will form sodium chloride. React with iron, it will form iron 2, iron 3 chloride. It also reacts with non-metals. Chlorine also reacts with phosphorus. It reacts with non-metals, but with the exception of oxygen, nitrogen, carbon, and noble gases. All other non-metals burn in chlorine to produce the corresponding chloride. So we can see phosphorus trichloride, it produces this, and phosphorus pentachloride. It's when it burns in phosphorus. So it reacts with other elements. All right, chlorine also acts as an oxidizing agent. Of course, it's a powerful oxidizing agent. When it reacts with iron 2 salts, iron 2 chloride, we can see it that it oxidizes the solution. Chlorine oxidizes green solution of iron 2 chloride to yellow iron 3 chloride. It oxidizes the iron 2 to iron 3 when it's also with triazosulfate 4. When it reacts with triazosulfate 4, when chlorine is bubbled through a freshly prepared solution of triazosulfate 4 acid, it oxidizes the triazosulfate 4 to tetraozosulfate 6. So it's a strong oxidizing agent. It's what we are trying to prove in this particular reaction. Okay, next thing is that it also reacts with hydrogen. Of course, when chlorine reacts with hydrogen, it's going to form what? A compound of that hydrogen, halide of that, which is hydrogen chloride. It also reacts with hydrocarbons. When it reacts with hydrocarbons, it reacts with hydrocarbon. A piece of filter paper saturated with a warm turpentine oil will rapidly catch fire in a jar of chlorine, forming soot and a misty fume of hydrogen chloride. So this is a mistake. It's supposed to be hydrogen chloride. It's supposed to be a hydrogen chloride. All right, with ammonia, it also reacts with ammonia to form hydrogen chloride, and nitrogen gas will also be formed, as we can see it here. Okay, it also reacts, it acts, one of the chemical properties is as a bleaching agent. Of course, chlorine is a powerful bleaching agent. Chlorine is commonly used as a bleaching agent, and it bleaches most dyes and inks in the presence of water, except that contains hydrocarbon, that contains carbon. All right, as we can see it here, the bleaching action of chlorine is due to its ability to react with water to form orthochlorate 1 acid, which is unsuitable to decompose to release oxygen, which oxidizes the dyes to form a colorless compound. All right, look at it here. As you can see, it's colored and colorless, So it has the oxidizing, the bleaching power from in a colored materials to a colorless one. Okay, so far we want to talk about the next reaction of chlorine, which is it reacts with alkalis. Alkalis are the soluble bases. It could be sodium hydroxide or potassium hydroxide. And when he does that, it will form sodium. If it is sodium hydroxide, it will form orthochlorate 1, sodium orthochlorate 1. If it is potassium orthochlorate 1, then plus sodium chloride and water will be formed, as we can have them here. So it also acts as it reacts with alkalis. It also reacts with slake lime. Slake lime. Slake lime. Slake lime is calcium hydroxide. Bleaching powder is produced by bubbling chlorine through the freshly prepared solution of calcium hydroxide. Calcium hydroxide. And it will produce bleaching powder. This is it. Bleaching powder. All right. How can we test chlorine? How can we test it in the lab or anywhere? We can test it with this method. This method, number one, is moist litmus paper. Chlorine readily bleaches moist litmus paper. If a moist blue litmus paper is used, it is first turned red before it is finally bleached. It is because chlorine gas is acidic. If a moist red litmus paper is used, chlorine bleaches it directly. So it has a bleaching power, bleaching effect on litmus paper. All right, when we use starch iodide pepper test, chlorine turns moist starch iodide pepper blue because it displaces iodine from the iodide. Of course, we have said that before, displacement effect, one of the physical properties of chlorine. So the iodine is being liberated, then turns the starch blue. You can see the equation for the reaction. It will displace the iodine here, and it will be potassium chloride, and the iodine will be liberated, and it will be blue, of course. Okay, what can we use chlorine for? Chlorine is used as a bleaching agent, of course. It is used as a powerful germicide. It is used in the manufacture of important organic solvents such as trichloromethane, tetrachloromethane, and trichloroethene, and others. It is used in manufacture of plastic, polyethylene, and polyvinyl chloride, and all of that. It is being used in manufacture of hydrochloric acid and the domestic antiseptics. It is being used in manufacture of potassium triosochlorate 5, which is used in making matches and fireworks, and sodium triosochlorate 5. Chlorine is what we have discussed so far. What it is, its oxidation state, how it can be prepared in the lab, physical properties, chemical properties, how to prepare it even in the industry, and its uses. This is what we have discussed, and how to test chlorine. That is the end of the video. For further discussion and inquiry, you can get to me with my phone line and WhatsApp line +23408 655 73229, or you can send me email to my email address with crystal116@gmail.com. Thank you for being part of this particular class, and remember, still remember to watch the next video. Thank you.